Hi, in this video I'm going to show how to set up the MC-CT speed axis function block from the Control Techniques CT-NC axis interface library. Once the axis is configured, I'll demonstrate how the main features of this interface work. So, in terms of hardware and connections, we've got a laptop. The laptop's been loaded with Control Techniques Connect software, and it's also been loaded with Beckhoff TwinCAT XAE shell. There's an Ethernet connection from the laptop through to the Beckhoff hardware, which in this case is a Beckhoff IPC, but the steps would be the same if it was a PLC or controller from Beckhoff. One of the ports has been configured for EtherCAT comms, and there's a connection through to an SI EtherCAT, which is plugged into a Unidrive M700, making this an EtherCAT axis. Now, if you've got one of our dedicated servo products, such as Digitax HD M753, this interface is built into the product, but the steps that you'll find in this video are identical regardless of the hardware platform. So before we get into the demonstration, I just want to point out that all of the information and steps that you'll find in this video are covered in detail in this user guide, which is linked in the description along with the CT-NC axis interface library. It's free to download for anybody, and if you basically don't want to take notes whilst you're watching the video, or simply you prefer to learn from a manual with step-by-step instructions, we've got you covered. So let's get into the demonstration. So what I'm going to do this from ground up, and we'll start off and I'll make a new project called MC-CT speed axis. And there we go. So just wait for the project to build. And there we go. So first thing I'm going to do, I'm just going to clean out anything that I don't want in the project. Let's hide all of this stuff because I'm not going to use any of it. Next thing, we want to tell it about our target. So I've connected my target before, so I'm going to select it. Then we want to expand the I/O and then search for any devices. So this is going to go and find our EtherCAT port, which it has, which is the EtherCAT port on the IPC. And I'm going to scan for boxes. In a sec, it will find our drive. There we go, it's found that, Unidrive M700. And I'm going to say OK to adding an NC axis, because that's the type of axis that we're going to be configuring. So there we go. At this point, probably what you'd do is you'd activate the configuration. That would get ADS communications working, and then you would be able to go and use the Connect software in order to configure the drive. However, I've done that ahead of time to try and shorten this video, so I'm going to continue on with the rest of the steps. So next thing that we want to do is we want to go and add somewhere for our PLC code to live. So I'm going to select standard project, and then so MC-CT speed axis. I'm just going to reuse the same name, give that a second, and there we go. We can see that our normal project items are there for us. So the next thing that I want to do is I just want to go and set my task times to something sensible. So I'm going to go and set these down to 1 millisecond, because 10 milliseconds is a bit on the slow side. That's already been done. Just make sure the axis time, there we go. I'll set this all down to 1 millisecond, so it's a sensible time. Okay, so we've done that. The next thing that we want to do is we want to go and update our libraries. So libraries in the TwinCAT world are under this folder called References. And we've got a few libraries to add, so let's go about setting up those. So we want to go to Motion, and we want to do PTP, and we need these two for a speed axis. If you were doing a position axis or EGB, you'd need all three, but for this axis we only need the two. And I've got to add them individually because you can't do them as a block add in this environment. So there we go, that's those two libraries. Next we want to add the EtherCAT stack library, so we can use SDO comms because the function block uses SDO comms to be able to get hold of information from the drive, like its trip history, for example. And then last of all, we need to add the library from Control Techniques itself. Now I've already got the library installed, but I'll just show you very quickly. If you go PLC, library repository, install, go and hunt to the location for the library file, that will install it into your system, and it will be added under this Control Techniques heading. So I'll close that and just go and add the library. So it's add library, control techniques, applications, CT NC axis interface library. There we go. So that's everything that we need to add in terms of libraries. Next step, let's go and add some code. So first thing that we want to do is we want to add our axis ref, because all Beckhoff TwinCAT NC axis require an axis ref, because that's part of the PLC open standard, and that's the standard to which the NC axis library is written to. So let's do that. So axis 1, axis ref, and there we go. Next thing, we want to add our axis implementation, which in this case is the speed axis. So it's axis 1 speed is what I'm going to choose to call it, and that is of type MC CT speed axis. There we go. Okay, so that's everything we need to do in terms of declaration. Next thing I'm going to do is I'm going to add a place to put code in LD, and the reason I'm using LD and not structured text is simply because it's just a bit easier for me to show you the interface in LD than it is in structured text, so we can get through the video quicker. So that's what I'm going to do. So I'm going to choose to add an action, and I'm going to call that motion. There we go. So I'm going to go back to main, and I'm going to call that action. There we go. So now we've got everything declared that needs to be declared, and we've got a place to run our LD code, and it's being serviced from main. So now I'm going to go to motion, and then I'm going to drag in our ENO box. I'm going to go and delete this contact that it brings in with that, and then I'm going to type in our instance name for the motion interface, which, if you remember, was axis 1 speed. There we go, there's the interface. You just have to delete these extra question marks, and then I'm going to input the axis 1. And there we go. That's basically everything you need to do in terms of declaring and getting an interface into your project. So what I'm going to do now is build. And we build at this point because what we want to do is push this axis into the list of selectable axes for linking up our NC axis under the motion category. So there we go. I think that's gone through without any errors. And first thing, go to settings, and I'm going to go linked to PLC. And you'll see that there we go, axis 1, so that's our instance of axis ref, has appeared in this list, and it's linked. Next thing that I'm going to do is I'm going to go and set up our encoder scaling. So this is a scaling from encoder counts, which is what you see from the encoder, and into user units, which is what we use to specify speeds and positions and whatnot. So the numerator, this is a number of user units. The way I tend to scale is I say the number of user units per revolution, and then I say the number of encoder counts per revolution. And the simple reason for that is it just makes your scaling a lot easier. Generally, you do know what your number of encoder counts per rev is, and by default it's 16-bit, which is 65536. Now I'm going to choose an arbitrary number for my number of units per rev. I'm going to pick 1000, and the simple reason I'm using that is it just makes it a little bit easier to understand your units to encoder count ratio, because dividing by 1000 means that for every 1 unit you've got roughly 65 encoder counts. So there we go. And I'll set modulo as well. There we go. Okay, so that's everything that we need to set up in terms of the axis scaling. Now let's go and set up the other properties. So for my particular axis, I've calculated beforehand that it's 50,000 units per second is the maximum speed, so that's the equivalent of 3,000 RPM. So if you look in our drive configuration references, there we go, you can see that this particular axis has been set up for 3,000 RPM, so 50,000 is the same as that. So I'll come back here and set both of these to that. That way we can't stick in a reference to the axis that's larger than what it's prepared to accept. I'm also going to set these acceleration limits out of the way. In most applications, there's not really a good reason to have that. So what I'm going to set it to is 1 E plus 20, which is 1 with 20 zeros out of the way. And I'll do the same for this. 1 E plus 20, which So this is the largest number that's generally accepted as an L real value by all of the NC axis function blocks. And I'm going to do the same again for the jerk. This is for a different reason. This is so that if you put 0 at the input to any of the blocks, you will end up with a linear profile, which is quite a useful property. So that's it in terms of limits and defaults. And the only last thing I'm going to do is I am going to disable the TwinCAT limits for following error, because these just tend to make your axis stop on an implicit stop, and you'll probably spend half an hour trying to work out why that is. So there we go, that's all of that disabled. Now we're ready to apply the setup. Okay. Let's give it a second to sort itself out, and we're just waiting for the, there we go. So we've got the green background rotating on cog icon here, so we know that we're working properly. I'm now going to select the motion interface and I'm going to log in. And what you can see off the bat is that when you're looking at the block in LD, you've got things that are inputs on the left, things that are outputs on the right, and because they're stacked left and right, it means that you can see more of these on the page. So whilst you're kind of setting up and trying to learn the interface, this is probably the easiest way to get going. Okay, so the first category of inputs is CMD, which is for command, so it's telling the drive to action something. The next category is CFG, which is configuring a feature. And then we've got two sets of status outputs. So anything that says STS is for status. It just makes it easier if you're using programming and you're using IntelliSense to be able to get hold of status category inputs and outputs, commands and configures, because you can just go STS underscore and then you'll just have a list of all of these things in your software. So I'm going to briefly run through the inputs. So we've got command drive on, which is linked to STS drive on. So what drive on is saying is, from the point of view of this block, enable the product. So let's go and do that. There we go. We can see drive on has become true. We can see that the drive is enabled, so that's 24 volts passed into the STO input. We can see that the drive is okay, so that means there are no trips and the axis is ready to run. So we can confirm that. So if I go into connect and go online, what you can see is that the status of the drive is in run. So that means we're ready to accept a reference, which is good. So next thing, we've got axis reset, so that if you ever cause a PLC open type error, like you put in something like a speed that's bigger than 50,000 units, your upper limit, you would need to use axis reset in order to reset that. But equally, if the driver's got a trip, then you can see that drive OK is false, then you can use axis reset to reset the drive as well. So no matter what activity, what type of thing it is that you're trying to reset, this is like a universal reset, it does everything. I'll next show jogging. So at the moment you've got jog speed, acceleration, deceleration rate and jerk. So if in fact, let me just put the video on so you can kind of see it working. There's a little bit of a delay in the video, but I think it will be okay. So there we go. There we go, working. You can see jogging forward. You can also see that jog has become active, and you'll see that for all of the reference there's an equivalent reference active output, so you can tell that that particular reference is working. So next thing, let's try the speed. So the idea is that the jog reference is for something like manual buttons. So the user's got a button pack and they're manually by eye positioning the axis. So the speed reference is more or less the same thing, only it's intended for automated running. So here we go, we can see that the speed reference is running using our speed target, A cell, D cell and jerk. Okay. One thing that's a little bit nicer about this interface compared to just using the normal NC axis function blocks is that all of the rates for these two references are dynamic. So instead of having to stop and re-execute the block again or execute another instance, you don't have to do any of that. You can just change the speed. So I'll just put in a slower speed here of 200 units per second. And now you can see that that has been applied. Next thing that you've got, which I'll just show now, is motion stop. So the idea is that this could be used as part of a controlled stopping regime that could be part of an emergency stop, but can't be used as an emergency stop on its own. So let's just try that. And it's overriding. So there you go. That's caused it to stop. It doesn't matter what I do, you know, with the speed reference, it's not going to start again. Okay, because this this reference has priority. And you'll only be able to start it working again once motion stop has been set to false and you've reset whatever command reference that you've got. So there we go. So that's the axis running again. Okay. So next we've got current limit, so you can set the torque producing current limit to the drive. By default it's set to 150, but your application may require a bigger number, but it's certainly enough to get you moving to begin with. You need to take a look at, you know, how much torque producing current your application is using, or indeed the load, which you can see from where are we? There you go, load percent. So basically this current limit will restrict the maximum load percentage that you can see down here. So next thing, we've got some at speed window, at position window, and those are all kind of related to basically this feature, which is stop on following error. So what you've got is the ability to define whether the axis stops on positional following error, speed following error, or speed and position following error, or none of those things. There's a dedicated deceleration rate for this feature, so that if it does automatically detect a following error, it will bring the axis to a stop using this particular rate. And there's a little bit of filtering in there, so you know, if you're getting the occasional following error during acceleration, you'd like to ignore that, you can set the time that we must be in following error in order to accept that. So that's pretty good. Next, you've got the error detection. So inside of this block, we're actually, you know, using the normal function blocks like MC power, MC jog, MC move velocity, MC move relative, etc. And you know, in order to be able to collect all of those function blocks together, you can imagine that there's error outputs for each of those individual blocks, and you've got to do something to be able to collate all of that information and put it out in a meaningful way. So what we've got is an error system where you can continuously monitor or make it single shots. If I double click on this, because everything is enumerated, you can select between all of the different options. So continuous update, one shot trigger. So you've got the ability to, you know, only trigger once and see what the first error is, for example. Okay. You've got the ability to focus on an individual MC type function block by saying pick this number. So if you've got an error and then you end up with a number for that function block, you can take that number from here, put it here, and then it will focus on that individual function block when it has a problem as a part of fault finding. So you've got a flag here that says, is it an error? Then the type of function block that's in error, the location that it is in the code, and then its individual number. So you've got a lot of quite powerful tools here to be able to identify where a problem is with an individual block. You've also got the PLC open state here that's in plain English so that you can read it, which is quite nice. So last the thing that I'm probably going to cover is the axis name. So we've put this in to give you the ability to not only name your axis, but this name for up to 16 characters actually appears in the drive and will appear in Connect. So let's take a look at that. So I'm going to go and change this name. So you always start with a single quote, and I'll call it, I don't know, Nidec drive. It's probably not the best name in the universe, but you'll see what I mean. So there we go. So I'm going to pass that into the target, and then what we can see in Connect is that now that name follows it. So you've got a way to be able to match up your specific axis with Connect, and also you get the ability to see that in the drive's display. So if I bring up menu 11, you can see Nidec drive. You've got the ability to see this actually coming down to the target. Now by default it had a number of 1001 in there, but that 1001 number is in fact the node number from the project. So if I close that, go drive, come on. Eventually, there we go, EtherCAT. Here's our EtherCAT address, 1001. So by default, it will put this number in, so you would have something to follow off of the bat if you're used to kind of looking for this number. So let's come back to the program. So we've kind of covered or touched on these. So we've got two values in order to be able to tell whether the comms are working. So SDS cyclic comms OK. That's basically telling us are our SDO reads up and working, so that we can read values like the trip values from the drive. This one tells us whether our EtherCAT comms overall is up and working. Basic drive status, which we touched on, is the current limit active, is the drive at speed, is the profile generator at the speed that we've asked for. Then we've got our motion active detection, so it'll tell us whether our jog reference is active or our speed reference is active. So if you've got some contention, like you've got speed selected and jog selected, it'll tell you which reference actually won that competition. We have also got hardware limits. So these two hardware limits, if I come back to here and then go limits, that actually relates to this pair of limits that you would have configured in Connect as a part of setting up the axis. So we've also got some other Boolean indications about whether it's inside of the following error and speed following error limits that you've configured over here. And then last of all, there's some basic metrics like, is the drive in alarm? What was the last trip? What's the sub trip? Load percentage, actual position, actual speed, and things to do with the following error. So that's a brief overview of all of the basic stuff. But the other thing that I wanted to point out before I carry on is that all the function blocks are open for you to view, and it's done deliberately so that you've got a means to kind of follow references through. If something's going wrong and you want to know, how you can set about fixing it, you want to be able to see the code. So what you can see is all of the internal software is divided into sensibly named categories. So, the implementation of MC power is in the power section, limits, jogging, speed, stopping. And if you want to go in and have a look at any of these, so we'll pick power for example, you go, I can go to instance, and there we go. Here's our instance of MC power, and here is all the software that's around it in terms of error reporting and whatnot. So you've got the ability to follow anything through, everything is commented so that you can see what each sort of piece of the code is in there to do. So there we go. I think I've covered all of the main points. Hopefully you found this useful. Thanks for watching.